Then the next type of reaction of metal carbonyl, that is the formation of carbonylate ion. Carbonylate. Many questions based on carbonylate ion asked in your CSIR exam. Carbonylate ion. Please listen. What is carbonylate ion? For example, a metal carbonyl. A metal carbonyl on reduction. Metal carbonyl on reduction. You will get an anionic complex. Anionic complex means a negatively charged complex. Okay? Metal carbonyl on reduction, you will get an anionic complex or negatively charged complex. This anionic complex is called carbonylate ion. Okay? This negatively charged complex is called carbonylate ion. For example, CO4 2 negative. First example, CO4 2 negative, then MnCO4 3 negative, then FeCO4 2 negative. Is it not CO4 2 negative? CO4 negative. Only CO4 negative. Then CrCO4 4 negative. CrCO4 4 negative. FeCO4 2 negative. MnCO4 3 negative. CoCO4 negative. This FeCO4, these are some typical examples. Some examples. This FeCO4 2 negative is called Coleman's reagent. A very useful synthetic reagent in organic chemistry. Okay, Coleman's reagent, FeCO4 2 negative. All these obeys 18 electron rule. All of them obey 18 electron rule. For example, cobalt 9 plus 8 17 plus 1 18. This obeys 18 electron rule. Here manganese 7 plus 8 70. Manganese 7 plus 8 15 plus 3 18. Then iron 8 plus 8 16 plus 2 18. This also obeys 18 electron rule. Chromium 6 8 plus 6 14 plus 4 18. So generally carbonylate ion obeys which rule? 18 electron rule. So I think you get an idea. The negatively charged metal carbonyl complex is called carbonylate ion. Many applications are there for this carbonylate ion. How you can prepare a carbonylate ion? Take a metal carbonyl reduction, then you will get the corresponding anionic complex. That anionic complex is called carbonylate ion. The negatively charged metal carbonyl complex is called carbonylate ion. This FeCO4 2 minus is a very useful reagent, Coleman's reagent. So first one, synthesis. Synthesis of carbonylate ion. Synthesis of carbonylate ion. Okay, synthesis. First method of synthesis, reduction. You have to take a metal carbonyl, then reduction by using any of these reagents. Alkali metal, popular alkali metals like sodium or lithium or potassium, or alkali metal hydride, for example lithium hydride, sodium hydride, potassium hydride, etc. Okay, so you can use alkali metals or alkali metal hydride, or you can use the hydride donor sodium borohydride. We already discussed many hydride donors in organic chemistry reagent section. Such hydrides can also be used as the reducing agent. So a metal carbonyl on reduction by using alkali metals or alkali metal hydride or simply a hydride donor reducing agent, you will get the corresponding carbonylate ion. Corresponding carbonylate ion will be formed. For example, first question, you have to write the product CO2 CO8. CO2 CO8. Reduction by using a reducing agent LiH BET thrice. LiH BET thrice. This reducing agent we discussed in organic chemistry. A lithium borohydride derivative reagent, alkyl lithium borohydride. It's a hydride ion donor. It's a reducing agent. What will be your product? Reduction of metal carbonyl. Reduction. It's a reducing agent. This is a reducing agent. Reduction of metal carbonyl will result in carbonylate ion CO2 CO8. If two metals are there, divide equally. CO CO4. CO CO4. What is the electron count of this one? Always product will obey 18 electron rule. Here cobalt 9 plus 8 17. So add one more negative charge 18. 9 plus 8 17 plus 1 18. So your product will be CO CO4 negative according to 18 electron rule. According to 18 electron rule. Then next one you can easily write the product Mn2 CO10. Mn2 CO10. On reaction with potassium hydride, KH, an alkali metal hydride. This is a reducing agent. Definitely metal carbonyl will be converted to its carbonylate ion. If two metals are there, divide equally. Mn2 CO10 become MnCO5. Okay. Then the negative depends on 18 electron rule. Find the tech. Manganese is 7, 5 into 2 10. So 10 plus 7 17. One more required. So MnCO5 1 negative. MnCO5 1 negative. If you know 18 electron rule, you can write the product. Okay. Then next question. All these are reduction method. Reduction. Reducing agent. Next one. Fe. Then here carbon monoxide, here CP, here also your CP ligand, eta 5 CP, carbon monoxide with the sodium. You know sodium is a reducing agent. What will be your product? But here two metals are there, so divide equally. So what do you get? Fe, CP, CO. What is the electron count? 8, 10, 12 plus 5, 17. Add one more electron plus 18. So that will be your product. So product according to 18 electron rule. Okay. Then fourth question. VCO6 on reaction with sodium. VCO6 on reaction with sodium. What is the electron count of vanadium? Scandium, titanium, vanadium. 5 plus 12. This is only a 17 electron species. Not 18 electron, 17. But your product must be 18 electron. Sodium reducing agent, it will provide electron. So your product will be VCO6 negative. What's electron count? 12 plus 5, 17 plus 1, This is an 18 electron species. Okay, then fifth one. FeCO5 iron pentacarbonyl on reaction with a reducing agent like sodium or lithium or anything. What is the electron count of FeCO5? FeCO5 8 plus 10. This is already 18 electron species. Then on reduction what will be formed? Already 18 electron species. Addition, if you are adding one negative charge, that become 19. If you are adding two negative charge, that become 20. So your product, the carbonylate ion must satisfy 18 electron rule. So what's the product? In this case, one carbon monoxide is eliminated. One carbon monoxide is eliminated. In the presence of reducing agent, one carbon monoxide is eliminated, become FeCO4. What is the electron count of FeCO4? 8 plus 8, 16. So in order to become 18, add 2 negative charge. So FeCO4 2 minus is called Coleman's reagent. This is one of the method of preparation of Coleman's reagent. How we can prepare Coleman's reagent? One of the many method of preparations are there. One method of preparation, take iron pentacarbonyl, on reduction 1 CO eliminated to form FeCO4 2 minus, which is called as Coleman's reagent. Okay, then next question. Next one, Fe3CO12. Fe3CO12 on reaction with the sodium in the THF solvent. You know sodium is a reducing agent. What will be the product? Three metals are there. Divide equally. Fe3CO12. So that become FeCO4. Fe equally divide into 3. FeCO4. In order to become 18 electron rule, 2 negative. That is the Coleman's reagent. The next method of preparation. Fe3CO12 on reduction. Okay, then next question, CO4 CO12 with the sodium reducing agent. What will be your product? CO4 4 metals are there. Divide equally into 4. CO thrice. Then must satisfy 18 electron rule. Cobalt 9 plus 6 15, so 3 negative. CO4 3 negative. So this is the method of preparation of carbonylate ion. A metal carbonyl on reduction will give the corresponding 18 electron carbonylate ion. But in all the above cases, the carbonylate ion formed having -1 charge or -2 charge. If you are using the reducing agent sodium, alkali metals or alkali metal hydride or such reducing agents. But instead of if you are using the reducing agents, lithium in liquid ammonia, that is the Birch reagent, or sodium in HMBA. What is HMBA? Hexamethyl phosphonamide, or lithium in naphthalene, or sodium in alkali metals in crown ether. Alkali metals in crown ether. All these are more powerful reducing agents. Okay, lithium in liquid ammonia, sodium in HNBA, lithium in naphthalene, alkali metal crown ether. Super reduced carbonylate is formed. Super reduced carbonylate ion is formed. Super reduced carbonylate ion. For example, this is FeCO5 iron pentacarbonyl. In the first step on reaction with sodium in liquid ammonia. You know iron pentacarbonyl is an 18 electron species. So it's a reducing agent. In the first step, one carbon monoxide is eliminated so that you will get FeCO4 2 negative. This is also 18 electron. This also obeys 18 electron rule. But in the next step on reaction with the more powerful sodium in HMBA, hexamethyl phosphoramide, super reduced carbonylate ion is formed. Again one carbon monoxide is eliminated. Then you will get FeCO thrice. How many negative that I have to add? 8 plus 6 14. So 4 negative. So your 2 negative will be converted into the super reduced 4 negative. So if you are using sodium in liquid ammonia followed by sodium in HMBA, more powerful reducing agent, super reduced ion will be formed. So that's a super reduced carbonylate ion. Okay. So depending on the reducing agent, your product will be different. Okay. Then next question. But all the products in accordance with the 18 electron rule. Another example. Example 2. Second example. Mn2CO10. First step, sodium in liquid ammonia. A product A will be formed. A on reaction with sodium in HMBA, hexamethyl phosphoramide. A product B will be formed. Identify A and B. This type of questions asked in CSA NET exam. What will be product A and B? Mn2CO10 reducing agent. Definitely your product A will be a carbonylate ion. Two metals are there. Divide equally. MnCO5. What is the electron count? 7 plus 10, 17. Add 1 negative. So this will be A. This A on reaction with the more powerful sodium in HMBA. Sodium in HMBA is a more powerful reducing agent. So what happens? Further reduction. Here already this is an 18 electron species. So further reduction, CO will be eliminated. Minus 1 CO. 1 CO is eliminated. So what will be your product? MnCO4. MnCO4 3 negative. Is it obeys 18 electron rule? 7 plus 8 15 plus 3 18. That obeys 18 electron rule. Okay, so very important. Then write a homework. Please write a homework. Write a homework question. CO6 with sodium in liquid ammonia, a product A will be formed. A on reaction with sodium in HMBA, a product B will be formed. Practice this question as a homework. Second one, second method of preparation of carbonylate ion. First we completed reduction. Second one by nucleophilic attack. By nucleophilic attack. Okay. So please listen. Iron pentacarbonyl FeCO5 on reaction with NaOH. Nucleophilic attack means here the nucleophile used is OH minus. Which nucleophile is used? The nucleophile used is OH minus. So iron pentacarbonyl on reaction with the sodium hydroxide, you will get a product A with again excess NaOH. If excess NaOH is present, this A will be converted into B. This is a previous year question of NET exam. So your product will be a carbonylate ion. So this is a method of preparation of carbonylate ion. So what will be the reaction? Iron pentacarbonyl on reaction with the sodium hydroxide, a product A will be formed. A on further excess NaOH if present, that will be converted into product B. Okay, the product A is HFE CO4 1 negative, and product B is FeCO4 2 negative. FeCO4 2 negative is actually Coleman's reagent. So this method is actually a method of preparation or synthesis of Coleman's reagent. So already we discussed the synthesis of Coleman's reagent, two methods of synthesis. Iron pentacarbonyl direct reduction. Here nucleophilic attack at iron pentacarbonyl. Nucleophilic attack. NaOH. OH minus is the nucleophile. First step is product is HFeCO4 minus. Second step Coleman's reagent FeCO4 2 minus. This will be your product. But I will explain the mechanism of this reaction also. What will be the mechanism? Okay. This iron pentacarbonyl can be written as FeCO4 double bond C double bond O. Due to back bonding, the carbonyl carbon, the C double bond exists as iron double bond C double bond O. Already we discussed in the previous section. Okay. Due to back bonding, one of the carbonyl can be represented in this fashion. Then what will be your nucleophile? OH minus will be the nucleophile. You know this carbon is electrophilic, having positive charge. This is a carbonyl carbon. Carbonyl carbon always positive charge. So O minus will attack the carbonyl carbon. This pi bond shift towards oxygen. So what will be the reaction? CO4 Fe double bond CO minus OH. Double bond C O minus OH. This will undergo resonance. In the next step, this will undergo resonance. What will be the resonance? This O minus will make a pi bond here. This pi bond shift towards this side. So your resonance will be CO4 Fe negative C double bond O OH. OH. Okay. C double bond OH. So here metal having a negative charge. This is alpha position and beta position, and that beta position containing a hydrogen. This is a very famous reaction called beta hydride elimination. In the reaction mechanism section, 4 important organometallic reaction: oxidative addition, reductive elimination, reductive coupling, beta hydride elimination. Elimination beta, alpha and gamma eliminations are there. Beta hydride elimination is possible when, with respect to the metal, here metal having negative charge, with respect to the metal at its beta position a hydrogen will be there. So what happens is this hydrogen will be transferred to the metal, then metal as H minus. This hydrogen will be transferred to the metal as H minus. Then you get transferred as H minus, then this bond will make a double bond here. So what do you get? Fe. Hydrogen is transferred to the metal, here CO4, Fe. Hydrogen transferred to the iron, overall charge negative, because one negative is still there in iron. Why? Because hydrogen comes to metal at the same time this bond breaks. This bond breaks as C double bond O, C double bond O. So a carbon dioxide will be your byproduct. CO2 will be your byproduct. So what do you get? HFeCO4 negative. Then this is product A. A on reaction with excess NaOH. You know the function of base to abstract an H plus, function of base to abstract an H plus. So OH minus plus H plus, water will be eliminated and you will get FeCO4 2 negative. The Coleman's reagent will be your product. So this is the mechanism of the reaction. Mechanism is also important for organometallic chemistry. This chapter is similar to an organic chemistry chapter. Okay, always the reaction. So it's a method of synthesis of Coleman's reagent, iron pentacarbonyl with the excess NaOH. In the first step, a metal carbonyl hydride is formed, HFeCO4 minus, then Coleman's reagent. This will be the mechanism. Once again, the mechanism, FeCO5 can be written in this fashion. OH minus will attack the carbonyl carbon, then undergo resonance. Then with respect to the metal, at the beta position a hydrogen will be there. That hydrogen will be transferred to the metal and CO2 is eliminated. CO2 is eliminated, so CO4 FeH minus. Further with the NaOH, FeCO4 2 minus, Coleman's reagent will be formed. This is also a preparation of carbonylate ion. Third and the last method of preparation by dispropanation. You know about dispropanation reaction. By dispropanation, last method of preparation of carbonylate ion. In dispropanation reaction, you have to take a binuclear metal carbonyl. For example, Mn2CO10. Binuclear means two metals are there. Mn2CO10. Popularly react with pyridine, or you can use ammonia, or you can use NH2R, similar like a non-pi acceptor ligand. Okay, so pyridine, ammonia, NH2R, etc. Popularly, pyridine is given in your textbook, B.D. Gupta textbook. So most probably pyridine based questions are asked in your exam. Okay, binuclear metal carbonyl with pyridine. Your product will be Mn2CO10 equally divided into MnCO5 and MnCO5. One become MnPy 5 times plus MnCO5 times minus. This will be your product. Okay, so what will be your product? MnPy 5 times plus MnCO5 times negative. Clear? So how find the electron count also? Find the electron count. One second. Find the electron count. Carbon monoxide is a 2 electron donor. 2 electron donor means 10 plus 7, 17 plus 1, 18. This is an 18 electron species. Okay. Then here pyridine is also 2 electron donor. Pyridine. So 5 into 2, 10 plus 7, 17, 16. So here not pyridine 5, pyridine 6. That is a correction. Okay. That's the correction. This is also 18 electron. Py 6. Okay. 18 electron. Your product must be an 18 electron species. Why? My question. Why it is called as a dispropanation reaction? In dispropanation reaction, one metal undergo oxidation and other metal undergo reduction. Here two metals are there, both of them having oxidation state equal to 0. Two metals are there, both of them having oxidation state is equal to 0. Here manganese plus 1, here manganese minus 1. So manganese 0 to plus 1. Increase in oxidation is called, increase in oxidation number is called oxidation. Here manganese 0 to minus 1. Decrease in oxidation state is called reduction. So in the binuclear complex Mn2CO10, two metals are there. One metal undergo oxidation at the same time other metal undergo reduction. So here a metal carbonylate ion is formed, MnCO5 minus, a metal carbonylate ion along with the byproduct MnPy6 plus. So this type of reaction only shown by binuclear carbonyl metal with these type of ligands. If ammonia is used instead of pyridine, ammonia. Okay, so this is called dispropanation reaction. So the three methods of preparation of carbonylate ion: first one reduction, second one nucleophilic attack, third one dispropanation reaction. So here a related question which is asked in TIFR exam. Please listen. one of the related question asked in TIFR exam, that is based on formation constant. That is based on formation constant. Okay, so you have to answer this. You know the concept, formation constant. Here MnCO5 negative, MnCO5 negative. In the first step with the pyridine, right constant is K1, right constant is K1. This become MnCO5, sorry, MnCO4 Py minus, in the next step again next pyridine, here one carbon monoxide is eliminated, minus carbon monoxide, here plus pyridine minus carbon monoxide, this is right constant K2, you will get MnCO 3 times, pyridine twice minus, the next step again next pyridine, one carbon monoxide is eliminated, right constant or formation constant, K3, MnCO twice, pyridine thrice minus, again K1 plus pyridine minus carbon monoxide, right constant K3, not K3, K4 etc. Finally you will get Mn pyridine 6 plus, So what is happening in every step? A previous question of TIFR exam. MnCO5 minus, first step one carbon monoxide replaced by pyridine. Okay, here MnCO4 pyridine. Next step again one carbon monoxide replaced by next pyridine. In the next step again one carbon monoxide replaced by another pyridine. So in every step one carbon monoxide is removed. My question, whether the rate constant or formation constant K1, K2, K3, K4 etc. which one will be higher? Or fast? In this process, which step will be fast step? Right is the right constant, or you can use equilibrium constant capital K as formation constant, which will be higher? Higher the rate, higher is the value of K. Okay, suppose the electron density at this manganese is electron density 1, at this manganese electron density 2, at this manganese electron density 3, at this manganese electron density 4. You know pyridine, here 5 carbon monoxide ligand, acceptor, pi acceptor. Here 4 carbon monoxide and a pyridine ligand. Pyridine is a donor ligand. Pyridine is a sigma donor ligand. Here 2 pyridines are there. So the pi acceptor carbon monoxide is replaced by 2 sigma donor pyridine ligand. Here 3 sigma donor ligand. So definitely in successive step the electron density at the metal increases. Why? Because an acceptor ligand replaced by a donor pyridine ligand. So definitely electron density 4 greater than electron density 3 greater than electron density 2 greater than electron density 1. Higher the electron density, higher is the back donation. So back donation 4 greater than, back donation 3 greater than, back donation 2 greater than, back donation 1. Back donation at 4 is higher. Higher the back donation, higher is the metal carbon bond order. So metal carbon bond order at fourth one greater than third one greater than, second one greater than fourth. So in this case, the manganese carbon monoxide bond is very strong. In this case, the manganese carbon monoxide bond is very strong compared to this one. Here also compared to this one, here manganese carbon monoxide bond very strong. So in the first step, carbon monoxide easily dissociate and pyridine is added. In the first step, carbon monoxide easily dissociate and one pyridine is added. But in the second step, due to higher back bonding, the manganese carbon bond is little bit strong bond. So it is difficult to break that manganese carbon monoxide bond and adding a pyridine. In the next step, more difficult. So very slow, because due to high back bonding, manganese carbon bond very strong. So it is difficult to break that. So what will be, which K value will be higher? Definitely K1 will be higher, K2, K3, K4, etc. Okay. In the first step, it is easy to dissociate. It is easy to dissociate the carbon monoxide because there is poor back bonding. Then in the successive step, due to the addition of a sigma donor ligand, electron density at the metal increases, back bonding increases, metal carbon bond order increases, bond is strong, difficult to dissociate the CO and adding a pyridine. So it's a previous question. K1 greater than, K2 greater than, K3 greater than, K4. The next one, reactions of carbonylate ion. Reactions of carbonylate ion. The first reaction is reaction of carbonylate ion. Your carbonylate ion behaves as a nucleophile. Carbonylate ion behaves as a nucleophile. So your first reaction, nucleophilic substitution reaction. First reaction, nucleophilic substitution reaction. So please listen. For example, MnCO5 negative. This is a carbonylate ion, an 18 electron species. On reaction with the methyl iodide. On reaction with the methyl iodide. You know, carbonylate ion behaves as a nucleophile. So it will attack a positive center. This nucleophile will attack a positive center. So definitely this negative charge will attack this positive center. I minus is eliminated. So your product will be methyl MnCO5. No negative charge. Find the electron count. Manganese is 7 plus 10 plus 1, 80. So that negative charge attack the methyl, SN2 attack I minus will be eliminated. Then second question. MnCO5 minus MnCO5 minus on reaction with the RC double bond OX, acyl halide. What's the reaction? Nucleophile will attack the carbonyl carbon, X minus will be eliminated. So your product will be MnCO5 RCO. Acyl group is a 1 electron donor. RCO is a 1 electron donor. 10 plus 7 plus 1 and 18 electron species. Then third one, MnCO5 negative on reaction with an allyl bromide. Okay, you know bromine is negative, so definitely this carbon will be positive. What will be the reaction? This nucleophile will attack this carbon, bromine is eliminated. So your product will be MnCO5 which is connected to 1, 2, 3 and eta 1 allyl, which is an eta 1 allyl. Okay, so this is the burst reaction of carbonylate ion. It shows nucleophilic substitution reaction. Then one of the previous question in NET exam based on nucleophilic substitution. Question is, Mn2CO10. Mn2CO10. First step on reaction with sodium in liquid ammonia, a product A will be formed. Next step A on reaction with bromine, Br, a product B will be formed. What is the reaction? You know Mn2CO10 is a metal carbonyl, sodium in liquid ammonia is a reducing agent. So first step, metal carbonyl on reduction gives a carbonylate ion. So equally divide MnCO5 negative will be the product because I am 18 electron species. In the next step on reaction with the bromine, Br2. In the case of bromine, one bromine negative, another bromine positive. So what will be the reaction? Nucleophile electrophile reaction. This negative charge attack the bromine. This Br minus is eliminated. So your product will be Br MnCO5 times. This is also a type of nucleophilic attack. So this is product A and that is product B. So the typical reaction of carbonylate ion is nucleophilic attack. So write a homework. Please write a homework. Homework. MnCO5 negative on reaction with Me3SiCl. Write the product. Trimethyl silyl chloride. That is the first question. Second question, CO4 negative on reaction with IPR, isopropyl bromide. So in these two cases, write the product. It is easy. Carbonylate ion simply shows which reaction? Nucleophilic attack. Then the very useful Coleman's reagent. Coleman's reagent. A carbonylate ion. FeCO4 2 negative. FeCO4 2 negative is called Coleman's reagent, a very useful reagent in synthetic organic chemistry. Okay, so FeCO4 2 negative, this is a carbonylate ion on reaction with alkyl halide RX. What will be the reaction? Nucleophilic addition. Definitely this negative charge will attack an electrophilic center. Halide is eliminated, so your product will be RFeCO4 2 negative become 1 negative. Why? Because 8 plus 8 16 plus 2, this is an 18 electron species. Here 8 plus 8 is 16. Alkyl group is 1 electron donor. 17 plus 1, product must be an 18 electron species. Okay, so the next step, this RFeCO4 negative on reaction with the carbon monoxide, on reaction with the PPH3, what will be the product? On reaction with the carbon monoxide or PPH3, what will be your product? That is my question. What is the electron count of this 18 electron species? What is the electron count of this one? 18 electron species. So what will be the product? What will be the product? If a carbon monoxide is eliminated and a new carbon monoxide is added, then nothing new product is formed. If R group is eliminated and the carbon monoxide is added, R group is a 1 electron donor, then you know the very famous reaction, migratory insertion. Migratory insertion. What is migratory insertion? Here metal having 4 carbon monoxide. Metal having 4 carbon monoxide. One of the carbon monoxide inserted between R group and metal. One of the already coordinated carbon monoxide inserted between R group and metal. Then RCO, FeCO, RCO, that one of the carbon monoxide inserted between R group and metal, then it become acyl group. Acyl group is a 1 electron donor. Then here 3 carbon monoxide is there. The incoming carbon monoxide also added. So FeCO4, what will be the charge? Negative. Then again find the electron count. Iron 8 plus 8 is 16. RCO is a 1 electron donor. Acyl group 1 electron donor 17 plus 1. This is an 18 electron species. Similarly, on reaction with the PPH3, already coordinated CO inserted between R and CO. So R, CO, Fe, CO thrice, PPH3 negative. Find the electron count. Metal 8 plus 6, 14 plus 16 plus 1, 17 plus 1, 18. This is also an 18 electron species. So in these cases, the famous reaction, migratory insertion. Clear? Migratory insertion. So Coleman's reagent on reaction with the alkyl halide nucleophilic addition are FeCO4 2 minus, or Coleman's reagent with the carbon monoxide or PPH3, what happens? Migratory insertion of already, if this CO is isotopically labeled, that isotopically labeled CO is inserted between metal and alkyl group, then incoming ligand. Okay, so very important reaction. Then some synthetic applications of Coleman's reagent. Then some synthetic applications of Coleman's reagent. Okay, you know Coleman's reagent FeCO4 2 negative on reaction with the alkyl halide Rx. What will be the reaction? Negative charge attack R plus, X minus will be eliminated. So you will get R FeCO4 1 negative. This on reaction with the carbon monoxide. What you get? Migratory insertion. One of the already coordinated CO inserted between metal and RCO, Fe. Incoming CO is added, then CO4 1 negative. That will be the product. Or you can directly obtain this product. Directly, this can be converted into that product by the reaction between acyl chloride, RC double bond O Cl. What's the reaction? Simple nucleophilic attack. Negative charge attack, carbonyl carbon. Cl will be eliminated. RCO FeCO4 negative. So this RCO FeCO4 negative. From this, many organic compounds can be synthesized. From this reagent, many useful organic compounds can be synthesized. RCO FeCO4 negative. RCO FeCO4 negative. So please listen. RCO FeCO4 negative. FeCO4 negative. If this on reaction with the, if this on reaction with the H plus, RC double bond OH, an aldehyde will be formed. RC double bond OH. If this on reaction with O2, RC double bond OO, that means an acid. In the presence of an H plus is also there in the medium. So an acid will be formed. Okay. If this on reaction with an R dash X, what happens? RCO minus will attack this R dash, RC double bond O R dash. A ketone will be your product. Your product will be ketone. If the same on reaction with a halogen X2, what happens? RCO minus will attack this halogen. Your product will be RC double bond OX. And an acyl halide will be your product. So this is derived from Coleman's reagent. So Coleman's reagent can be converted into many organic compounds. That is a synthetic application of Coleman's reagent. When Coleman's reagent reacts with acyl halide, RCO FeCO4 negative is formed. This one reaction with H plus and aldehyde is formed. This one reaction with O2 and carboxylic acid will be formed. This one reaction with RX, a new ketone will be formed. With halogen, acid halide is formed. So that's all about our carbonylate ion. The most important carbonylate ion is Coleman's reagent. Once again, I am repeating, what is carbonylate ion? Carbonylate ions having negative charge. When a metal carbonyl on reduction, carbonylate ion is formed. What will be the methods of synthesis? 3 methods of synthesis discussed. Typical reaction is nucleophilic substitution. And the last part in reactions of metal carbonyl, that is metal carbonyl hydrides. Metal carbonyl hydride. So what are metal carbonyl hydride? In metal carbonyl hydride, a metal is present, carbon monoxide is present, as well as hydrogen is present. Metal, carbon monoxide as ligand and hydride as ligand. For example, HMnCO5, then HCO4, then H2FeCO4 times. All these are examples of metal carbonyl hydride. Here manganese is the metal, 5 carbon monoxide and 1 hydrogen. Hydrogen has H minus, hydride ion. Cobalt is the metal, 4 carbon monoxide and hydride ion. So such a type of complexes are called metal carbonyl hydride. In the last lecture we discussed the acidity of metal carbonyl hydride. Okay, that's an important topic for our exam. Then how you can synthesize metal carbonyl hydride? Synthesis. First method, acidification of carbonylate ion. Acidification of carbonylate. You know what is carbonylate ion? We already completed carbonylate ion. Acidification. For example, MnCO5 minus. It's a carbonylate ion, an 18 electron species. Acidification with H3O plus, an acid. What happens? One H plus is transferred to this complex, so you will get HMnCO5, no charge. This is 18 electron, 10 plus 7 plus 1, 18. Product must be according to 18 electron rule. So the acidification of carbonylate ion will give metal carbonyl hydride. Another example, CO4 minus, on acidification H3O plus, you will get HCO4. Okay, similarly FeCO4 2 negative, Coleman's reagent, a metal carbonylate ion. Acidification H3O plus. First step, 1 hydrogen is added, then HFeCO4 negative. Again acidification, further acidification, you will get 2 negative cancelled by 2H2, H2FeCO4, H2FeCO4. Okay, so this is the method of preparation of metal carbonyl hydride. How to take a carbonylate ion? Simply acidification. Okay, then write the next question. VCO6 negative 12 plus 5, 17 plus 1 and 18 electron species. On acidification, H3O plus what happens? Negative charge cancelled by hydrogen. HVCO6. Okay, HVCO6, but this compound is not formed. What is the reason? What is the reason? Because here vanadium having coordination number 6 plus 1, 7. Coordination number equal to 7 is not possible. Coordination number equal to 7 for vanadium is not possible. Already we discussed in the previous lectures this case. Okay, so this reaction does not takes place. Then another special reaction, CrCO4 4 negative. Is it 80 electron species? 6 plus 8, 14 plus 4, 18. With liquid ammonia and ammonium chloride. Liquid ammonia and ammonium chloride, give a triple star mark, a previous year question. Here also a metal carbonyl hydride is formed. A carbonylate ion, here not direct hydrolysis, instead of liquid ammonia and ammonium chloride is used. Here dimerization takes place. Please listen to CrCO4, two hydrogens are added. That hydrogen acts as bridge. So 2 negative cancelled by 2 hydrogen. So remaining charge is only 2 negative. So a dimerized product. Please note this reaction. So this type of questions are favorite in NET and GATE exam. Okay, with ammonium chloride and liquid ammonia. So that's the first method of preparation of metal carbonyl hydride. Second method, by the direct addition of H2. By the direct addition of H2. For example, you have to take a binuclear metal carbonyl. For example, Mn2CO10. Mn2CO10. On reaction with H2. Binuclear, 2 metals are there. Divide the fragment equally. So what do you get? MnCO5. Add 1 hydrogen. So H MnCO5. Is it satisfies 18 electron rule? 7 plus 10, 17 plus 1, 18. Okay. If there is no hydrogen, Mn2CO10 with a reducing agent, carbonylate ion will be formed. Or CO2CO8. CO2CO8 on reaction with H2, what will be formed? CO2CO8. Divide the fragment equally divide. So CO 4 times. 9 plus 8 is 17, 1 hydrogen. HCO4. So that will be your product. HCO4. Okay. So this type of question is very favorite. A binuclear metal carbonyl, direct addition of hydrogen. So we discussed the 2 methods of preparation of metal carbonyl hydride. Third one. Nucleophilic addition. Nucleophilic addition. Already we discussed this reaction. Nucleophilic addition of OH minus. For example, you have to take iron pentacarbonyl FeCO5 on reaction with a nucleophile NaOH, you will get HFeCO4 negative. HFeCO4 negative. Is it satisfies 18 electron rule? 8 plus 8, 16 plus 1, 17 plus 1, 18. This is a metal carbonyl hydride. Metal carbonyl. Already discussed the mechanism of this reaction also. This is a metal carbonyl hydride. If excess NaOH is used, what happens? This will be converted into Coleman's reagent, FeCO4 twice. Mechanism also we discussed. First step, iron pentacarbonyl with a nucleophile HFeCO4 negative. Further, if you are using excess NaOH, it will be converted into a carbonylate ion, for example, Coleman's reagent, FeCO4 twice. Okay. Then Fourth method, by the reduction of carbonyl with hydride donor reducing agents, H minus donor reducing agents. By the reduction of carbonyl with hydride donor reducing agent. For example, iron pentacarbonyl, FeCO5. Okay, it is an 18 electron species. Reduction with sodium borohydride, NaBH4. You know, when a metal carbonyl compound on reduction, you will get the product carbonylate ion. But this passes through an intermediate. For example, in the first step, you know this is an H minus ion donor. This H minus will attack here, so that you will get H. One carbon monoxide is eliminated. Elimination of one carbon monoxide because it is 18 electron species. HFeCO4, one carbon monoxide eliminated. What is the electron count? 8 plus 8 is 16 plus 1 17 minus 18. So this is a metal carbonyl hydride. Then this will immediately converted into, if sodium borohydride is excess, this is converted into our ultimate product FeCO4 2 negative, metal carbonylate ion, or the Coleman's reagent. Okay, if sodium borohydride excess, sodium borohydride, so that is the reduction of carbonyl with the hydride ion donor, FeCO4 18 electron species. First step, adding a hydride ion, then one carbon monoxide eliminated, HFeCO4 negative, it's an intermediate, immediately converted into FeCO4 2 negative. Okay, then write a homework. CrCO6 with the sodium borohydride, NaBH4. Write the product. CrCO6 with the NaBH4. Write the product A. It's a special product. You can refer any textbook. Okay. So that's all about the preparation of metal carbonyl hydride. First method of preparation, direct acidification of carbonylate ion. Second method, direct addition to binuclear carbonyls. Third method already discussed, nucleophilic addition. Fourth method, reduction by using hydride ion or ligands, hydride ion reducing agents. Then metal carbonyl hydrides reactions. Only one reaction, insertion reaction. Insertion reaction means, for example, MnCO 5 times hydride, a metal carbonyl hydride, on reaction with alkene, CH2 double bond CH2. Okay, reaction is this alkene will be inserted into this metal hydrogen bond. This alkene will be inserted into the metal hydrogen bond. So what will be your product? CO5 Mn. Here manganese will be connected to CH2, single bond, double bond breaks, CH2 and hydrogen CH3. Insertion reaction. Similarly MnCO5 will insert into oxygen, O double bond CO2 will insert into CO2. What will be the product? The CO2 will be inserted into this manganese hydrogen bond. CO2 will be inserted into this bond. Insertion reaction. So your product will be CO5 MnCOOH. So this type of reaction shown by metal carbonyl hydride. So our topic reactions of metal carbonyl hydride is completed.